Welcome friends. So, as we were discussing with the help of different types of tools like we discussed in our last few sessions about the use of a very interesting tool of analytics, that is decision tree, how there are multiple options which are possible, and out of those multiple options we are able to decide which is the best possible outcome on the basis of various probabilities which are there for different types of alternatives. With the help of simulation also, we discussed that how you can have a good decision for your future, and all these are the nature of our prescriptive analytics, where we are giving a kind of a suggestion that out of various alternatives, which alternative is going to give you a better result. Moving into the use of these types of cases, we have another set of problems where we can use these types of knowledge in our real life situations. News vendor problems are very often discussed in our inventory management discussions, where the nomenclature of news vendor comes that you have a particular period where you have only single opportunity to procure, and on the basis of what decision you are taking, you have to survive for that entire period. So, the nomenclature comes from the philosophy that there is a newsboy who is there at a bus stand in the morning. He has only single opportunity to procure the newspapers, that what should be the optimal stocking quantity of the newspapers with that boy, so that in the day whatever demand comes, he is able to maximize his profit. So, he has to see he should not overstock. If he overstocks and the demand is less, he may incur some kind of losses because of some unsold newspapers are left with him at the end of the day. On the other hand, it is also possible that he stocked less, demand is more, and he is unable to fulfill that extra demand, and in this case he is not able to get the more profit or the profit which is possible, he is deprived of that particular profit. So, both these scenarios are possible, and in this scenario we need to decide what is the more suitable quantity which can take care both these types of costs. So, in this particular session we are going to discuss this particular case of inventory management, which is very popularly known as newsboy problem or news vendor problem. So, here, as I have already explained you the nature of the problem, then we will have some numericals, some data through which we will try to explain you that how our knowledge of analytics will help us in solving such type of problems. So, here I have some data with me, where you see that based on my past experience, we have a possibility of different levels of demand. If you see on the screen, I know that my demand can vary from 15 numbers to 29 numbers on a particular day. There can be a possibility that on a particular day only 15 units are sold, and it is also possible that on some other day 29 units are also sold. So, demand can be 15, 16, 17 and so on up to 29. The probabilities for different levels of demand are also given to me. This is again based on my past experience. So, these data is coming from past knowledge. I am able to assign, rather I am able to know what can be the demand labels, and for each demand label what can be the possible probability. So, the probabilities are moving from 1%, 2%, 3%, 5%, 10%, 12%, 11% and so on. These are the probabilities for all these different levels of demand, and the sum total of these probabilities are equal to 1. That is the important thing, that sigma of these probabilities should be equal to 1. Now, based on this particular information, let us see what are the possibility. Here you see simply this data. So, without going any kind of analytics, I can see that 22 has the maximum probability, 12%. 22 has the maximum probability. So, a layman will say that okay, we should keep 22 newspapers or 22 units of this product, because the maximum possibility is of 22 units on any particular day. So, it looks quite logical that the highest probability is with 22 units. So, we should stock 22 units. Now, I am having some more data with me, and using that data, let us calculate what is going to happen if I am stocking 22 units. Here we are considering the cost price of this product as 1 rupee and the selling price as 1 rupee 50 paisa. So, you can say that profit per unit 50 paisa. So, here we are considering the cost price as 1 rupee, selling price as 1 rupee 50 paisa. So, profit per unit is 50 paisa per unit. Now, as we just discussed that we should expect to procure 22 units. Now, let us see if I am procuring 22 units, cost price 1 rupee, selling price 1 rupee 50 paisa, profit 50 paisa. With this information, if I am procuring 22 units, let us see what is the cost. Cost is 22, Q equals to 22. I am procuring 22 units. So, whether demand is 15, 16 or any label, the cost price is 22. And then the revenue which I am going to get, that is also very interesting. If I am selling 15 newspapers, so one paper gives me 1 rupee 50 paisa, 15 newspapers will give me 22 rupees 50 paisa, and so on as I go up to here 16 into 1 rupee 50 paisa, 17 into 1 rupee 50 paisa, 18 into 1 rupee 50 paisa, 19 into 1 rupee 50 paisa, so on here 20 into 1 rupee 50 paisa, 21 into 1 rupee 50 paisa, 22 into 1 rupee 50 paisa. Now, the demand is 23, but since you have only 22 papers, here onwards your revenue is 22 into 150 paisa. It is not going to increase with increasing possibility of demand. It gets stagnated. And then you can calculate profit also for each of these possibilities, which will be revenue minus cost. So, you will have like in this case 22.50 minus 22, that is 50 paisa. Now, here you see the possibility of happening this profit of 50 paisa is just 1%. So, we will calculate another term which is known as expected profit, which is going to be the sigma of probability Pi into profit at I, and I equals to 1 to, let us say, if these are from 15 to 29, like in this particular case. So, for all the respective probabilities, you have to multiply their profits and then do the sigma, that is the calculation of this expected profit. For the sake of convenience, for the sake of saving the time, we have done this calculation, and this calculation gives us for this particular data the expected profit like if you see this table here, the cost is 22 for all these entries, the revenue is changing 22.5 and it is changing up to 33. Up to this level the revenue is changing. Why it is changing? I just explained you, and from here onwards it is same 33. So, whether the demand is more, but still you are getting only same level of revenue, and therefore, the sum total of 0.5 into 0.01 plus 2 into 0.02 and so on up to last 11 into 0.01, that comes out to be our expected profit. It is actually expected profit, not expected revenue, that is 9.395. Now, I request that whether it is the maximum possible expected profit or not, that we need to check, and that we can check. Now, you can do the same exercise by taking either 21 or 23, because for 21 also the probability is 12%. So, please see, if I stock 21 units, what is going to be my expected profit? Maybe 21 may give me more expected profit. So, I will decide to procure 21 units, maybe because the probabilities are very near 22, 23, 21, 12%, 12%, 11%, maybe 23 may give us more profit. So, we may do this by trial and error method or by doing all the computations again and again for these different labels. So, we have got a very direct method through which you need not to go for all these iterative calculations, hit and trial methods. You need to see that there is a direct method which can help you in determining that what is the optimal stocking level. Now, for that purpose, we want to have, okay, we have the calculation available with this 21 also. If I take this 21, our expected profit is this. So, now it is interesting, for Q equals to 21, expected profit is 9.495, and when we did the calculation with Q equals to 22, the expected profit is what we just calculated, 9.395. So, you can clearly see that by reducing the order quantity from 22 to 21, our expected profit is slightly higher. So, it is always advisable that I should keep this level of quantity, that is a better decision. But can there be a direct method also? Now, somebody will say, sir, why have you stopped at 21 only? Why not you try at 20 also? Maybe 20 will further increase your profit. So, we have to check on all these labels, and then you can understand how much huge amount of time and effort will be required for doing these calculations. So, for that purpose we have a simpler method, and in that simpler method, as I said in the beginning of this particular session, that if you are stocking more and the demand is less, for example, in this case if I stock 21 and on that particular day the demand remained to be 16 only, for example. So, you are wasting 5 units of your item. There is no need of these 5 units and these are wasted. On the other hand, you are stocking 21, but on that particular day the demand happens to be 26. Now, there is a possibility of earning more profit, but you are deprived of that particular extra profit. So, these are represented as cost of overstocking and cost of understocking. When you are stocking more and you have unsold items at the end of the day, these are contributing to your cost of overstocking. Cost of understocking, there is a possibility of more profit and you are deprived of that particular opportunity for gaining more profit. So, ideally we want to minimize both these costs and that will give us highest level of expected profit. Now, for that purpose we are considering a simple situation where we have defined how mathematically we are going to calculate this cost of overstocking and cost of understocking. You may remember our example where the cost price was 1 rupee, selling price was 1 rupee 50 paisa. So, cost of overstocking CO and cost of understocking is CU. Cost of overstocking is the cost price and cost of understocking is the profit which you are not able to earn, that is selling price minus cost price. Generally this is the beginning of this particular model, but it is also possible that if there are some unsold items, or you can say there is a value in the scrap also, there is a salvage value also. So, if salvage value is there, in that case if salvage value is there, if salvage value is represented as small l, in that case cost of overstocking will be C minus L, because some of your losses can be compensated by the salvage value which you are able to get at the end of the period if things remain unsold. So, now how are we going to develop the mathematical expression for this particular case? So, we are like to stock highest number of quantity. You see there is a cost of overstocking, another is cost of understocking. Now, you will like to stock as much as that by stocking this you are having more probability of increasing your expected profit than your expected loss. With any additional unit, this additional unit can result into profit also, this additional unit can result into losses also. So, as long as this additional unit is helping you in increasing your expected profit, you will keep increasing this number, but there will be a point where this additional unit may hamper your profit and may result into more losses, more expected losses. So, that is the our optimal level of stocking quantity. So, in this case the formula development works like this, that expected profit from stocking additional unit is more, expected profit is more than the expected loss from stocking the additional unit. So, profit, expected profit by the additional unit is more than expected loss from additional unit. Cu into probability demand is greater than equal to Q. Now, when will this expected profit will happen? That if demand is more, I am having this much of quantity, demand is this much. So, when demand is more than the quantity I am stocking, so by increasing the number of quantity, as long as I am coming to this level, by stocking additional number of units, I am able to increase my profit. Now, if this is the level of demand and if I further stock, then these stocking additional units which are beyond my demand level, these are going to result into losses. So, I can express this particular concept, this is the concept, and then into this mathematical expression as Cu into probability demand is greater than or equal to Q. This is the expected profit and the expected loss is Co into probability demand is less than Q, and this can be represented as Cu into probability demand is greater than equals to Q is more than Co into probability demand is less than Q, and then it can slightly be readjusted mathematically, and then finally we can write that probability demand is greater than Q is Co upon Co plus Cu. Probability demand is greater than equals to Q, this is cost of overstocking divided by cost of overstocking plus cost of understocking. Like in this particular case, we had cost price 1 rupee, selling price 1 rupee 50 paisa. So, our cost of overstocking is 1, cost of understocking is 50 paisa. So, our probability that demand is greater than equals to Q is equals to 0.67. Now, we got this probability label, but how to execute this probability label, let us discuss that aspect also. So, for the execution purpose, let us see that there are these are the different levels of demand where you have let us say now what does it indicate? That these are the demand and these are the probability, that there is a probability of 10% that demand will be 10 units. Demand can be 20 also, that again has a probability of 10%. Demand can be 30 units, it can again have a probability of 10%. But you understand that demand of 20, 30, 40, 50, 60 will only be possible when the demand of 10 has completed. Demand of 30, 40, 50, 60 will only be possible when you have completed the demand of 10 and 20 units, and so on. Demand of 60 is only possible when you have completed up to 50 level. So, because in this situation we have to calculate cumulative probability, and generally we calculate cumulative probability from top to bottom, but considering this scenario that cumulative probability will be highest for demand of 10 units, because in all these scenario only when you have completed 10 units, you have sold 10 units, then you can go to the higher levels of demand. So, we will make the cumulative probability table from bottom to up, like this. So, using this knowledge that how our cumulative probability tables are made, we are coming back to the example which we were discussing, that from 15 to 29 the demands are given, their probabilities are given. Now, in this case we will complete the table of cumulative probability, which is the last column, last row, which is 0.01, 0.05, and so on, going like this, and finally, the cumulative probability is 1 for 15 units. Now, the probability which we are searching, that is 0.67. The meaning is the probability should be equal or more than 0.67. So, as we are coming here, for 22 the cumulative probability is 0.6 and the next highest is 0.72, which is just higher than 0.67. So, this 21 becomes our optimal stocking level. 21 becomes our optimal stocking level, and this is what is the answer for this particular situation, that if I stock 21 units, I will be getting the highest, you can say, profit, expected profit, and I recommend to stock 21 units. You can do now, because we have already done the calculation, that if our Q star, that is the stocking quantity, is 21, the expected profit that we have already calculated is 9.495. That is our highest expected profit. Yes, our quantities may change. How? For example, there is a salvage value also given in this case. For example, our data says that we have 1 rupee cost price, selling price 1 rupee 50 paisa. Now, if salvage value L is, let us say, 25 paisa. So, in this case, my cost of overstocking will become 1 minus 25 paisa, that is 75 paisa. Cost of understocking will remain same, and in this case my probability will be 0.75 upon 0.75 plus 0.50, and this will be 0.6. And now, when I see 0.6, it is possible that you will have this probability level if salvage value of 25 paisa per unit. I request all of you to please calculate what will be the expected profit, if I have salvage value of 25 paisa. That is again going to be an interesting calculation, and you have to apply some extra mind for calculation of expected profit, because why I am asking you to do this calculation, we already have in our this class the calculation of expected profit for Q equals to 22, that is 9.395. But since now salvage value is also available, that expected profit calculation will change. So, that is what I want to know, that if you have salvage value also, what will be the expected profit. Yes, I have given you the answer that the highest expected profit will be at Q equals to 22, but I have not given you the answer what will be the expected profit at that particular level. So, please do that calculation, and in our next session we will like to discuss the answer of that question, and also what is the concept of cycle service level in association of this particular algorithm which we are discussing. With this, we come to end of this particular session. Thank you very much.